Projectiles. Projectiles are objects where they are accelerating downwards due to gravity, but also have horizontal motion. For example, balls in tennis, football, etc., arrows, snowballs, ski jumpers are all projectiles. The monkey and hunter experiment shows us how to deal with projectiles. Here we have the situation with a monkey hanging from a tree and a hunter with a gun. The gun is directly in line with the head of the monkey. The monkey has the idea that if he lets go of the tree at the instant the gun is fired, the bullet will go over the top of his head. But in fact this is what is found to happen. The bullet falls at the same rate as the monkey, and so the monkey has no chance. In reality, this experiment can be done in the lab, firing ball bearings at falling cans. This shows us that the vertical motion is independent of the horizontal motion. An object falls at just the same rate, whether it has horizontal motion or not. This means we can deal with the vertical and horizontal motion separately. Let's look at this in a problem. A stone is thrown horizontally at a speed of 9 meters per second and hits a wall 2 meters away. Calculate how far the stone will have dropped and its velocity on impact. Well, as with all constant acceleration problems, I'll start by writing down suvat, but I'm going to specify that this is in the horizontal direction. I'll also write down SUV-GT, where the acceleration is the acceleration due to gravity g. This, I'll specify, is in the downwards direction. I can now start putting in the data. My initial horizontal displacement is given in the question at 2 meters. The initial horizontal velocity is given in the question at 9 meters per second. Ignoring air resistance, the final horizontal velocity will also be 9 meters per second, meaning there is zero acceleration. We're not asked for the time, so I'll leave it blank for the moment. My vertical displacement is what we want to find. My initial vertical velocity will be 0 meters per second. The stone is thrown horizontally. My final vertical velocity I need to find. The acceleration g is 9.81 meters per second squared. Note I've specified the direction as down, and therefore g is positive, and I don't need this time. What I do know is that these two times will be the same, and I'm actually going to find those to start with. Using the simple equation speed equals distance over time rearranged to time is equal to the displacement over the velocity, which is 2 meters over 9 meters per second, using my horizontal data, gives a time of 0.22 seconds. That's the time of flight. I can add my times to my data table just in case I need them again. Next, I'm going to use s equals ut plus a half gt squared to find my vertical displacement. That is, how far the stone will have dropped. Putting in the numbers, s equals 0 times 0.22 plus a half times 9.81 times 0.22 squared, which comes out at 0.24 meters. Then, using v equals u plus gt to find my vertical final velocity, putting in the numbers, v equals 0 plus 9.81 times 0.22, a vertical velocity of 2.16 meters per second. So I now have the horizontal velocity and the vertical velocity, but to find the velocity on impact I need to find the actual velocity of the object including its direction. So for this I'll need to put in the vectors. Here we have the horizontal velocity at 9 meters per second, the vertical velocity at 2.16 meters per second, and this will be the resultant, which I can find using Pythagoras as v is equal to the square root of 9 squared plus 2.16 squared, giving a velocity of 9.26 meters per second. I still need to specify a direction, so I will find this angle theta. Tan theta is equal to opposite over adjacent, 2.16 over 9, which gives theta at 13.5 degrees. So now I can finalize my answer and say that the stone has dropped 0.24 meters and has a velocity of 9.26 meters per second at an angle of 13.5 degrees to the horizontal. Let's look at another problem. A ski jumper leaves a ramp angled at 20 degrees to the horizontal at 25 meters per second. Calculate their velocity on landing, time of flight and horizontal distance. I'm going to start by drawing in the velocity and adding a line here so I can show that it is at 20 degrees to the horizontal. To find the horizontal component of velocity, I need to resolve across the angle, and so this will be 25 cos 20 degrees, or 23.5 meters per second. The vertical component is resolving away from the angle, and so is 25 sine 20, or 8.6 meters per second. Now to gather my data in the horizontal and vertical directions. My horizontal displacement is something I need to find. My initial horizontal velocity I've found here, 23.5 meters per second. Ignoring air resistance, the final horizontal velocity will be the same, meaning acceleration is 0 meters per second squared, and this time I need to find the time of flight. My vertical displacement will actually be 0. The skier will go away and then back to their initial vertical height. My initial vertical velocity I've found here, 8.6 meters per second. The minus sign because here I'm specifying down as positive and the skier starts by going up. My final vertical velocity I don't know, and I need to know. The acceleration is due to gravity, positive because I've taken down as positive at 9.81 meters per second squared, and the time will be the same as this one. I've copied across my horizontal and vertical data just to refer to. First I'm going to use v squared equals u squared plus 2gs to find my vertical final velocity. Putting in the numbers, this is minus 8.6 squared plus 2 times 9.81 times 0, the 0 meaning this whole thing disappears, meaning that v squared is equal to minus 8.6 squared, or v is just equal to 8.6 meters per second. So now I can do a diagram with my horizontal velocity of 23.5 meters per second, my vertical velocity of 8.6 meters per second, meaning this will be the resultant or final velocity. Using Pythagoras, I can say that v squared is equal to the square root of 23.5 squared plus 8.6 squared, which gives v of 25 meters per second. You'll notice that the final velocity is the same as the initial velocity was. To find the angle theta, well, tan theta is equal to 8.6 over 23.5, meaning theta is 20 degrees, the same angle that the skier started off at. So the skier lands with a velocity of 25 meters per second at an angle of 20 degrees to the horizontal. I've copied my data across to this table, but now added my final vertical velocity of plus 8.6 meters per second. I can now use v equals u plus gt to find t. I've rearranged it to give t is equal to v minus u over g. Putting in the datas, v is 8.6 minus 8.6, so this is then added over 9.81, gives a time of flight of 1.75 seconds. I can add that here, but it's also the same time as here. And finally, using displacement is equal to velocity times time to find the horizontal displacement, I can use 23.5 for the velocity times 1.75 seconds for the time, giving a horizontal displacement of 41.1 meters. Summing up, the skier is in the air for 1.75 seconds and covers a horizontal distance of 41.1 meters.